Hey everyone, this is Larry. This is day 11, I guess, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord as we, journey to this problem together. It seems like the problem is diameter of the binary, I can't even read correctly. Diameter of binary tree. You should solve this live, hit the like button, subscribe button, join me on Discord. Wait, I always said all this. I don't know. Sunday night is always a little bit weird, maybe. Okay. Yes, C++, I don't know why. I mean, the why is because I think I solved the last problem in C++, but okay. Given the root of binary, return the length of the diameter of the tree. The diameter of a tree is the length of the longest path between, okay. So given that this is a tree, yeah, I mean, I think we can actually just may or may not pass through the root. Okay. Yeah, I mean, I think this is so some of my hesitation is that I was curious why this is easy. I mean, I don't maybe it's not. I don't think it's so bad, but I think it's probably a little bit harder on the easy one, or harder than the ones that I've been seeing lately, where they just ask you to do for loops. So I think I just kind of took an extra second there, but yeah, I think for problems like this, just try to think about especially for Yeezys and maybe even mediums, I think one advice I would have is try to figure out how to do it in a brute force way, and then try to think if you can do it a little bit smarter. What is n in this case? N is 10 to the 4th, so n squared is going to be too slow, but try to think about the some sort of invariant or way of doing it, so that you know that you've done every possibility, right? So in this particular problem, I just think about each node, and if this node is the, I guess, LCA, the lowest common ancestor between two nodes that are the longest path, what would that be, right? And that is just basically, that means that if the longest path goes through this node as the root of the node of the longest path, then what does that mean? That means that you just take the longest path from the left and the longest path from the right, and then combine them together, right? And then we do that for every node, then we basically is doing brute force, because then you're asking, okay, for every node, what if this is the root of the longest path? And if we do that for every node, then we effectively answer the question. And of course, so that's basically the idea to start with, and then you're going to have to try to do that in this case, linear time, or n log n, but I find n log n doesn't come up that often in tree problems. I know. If you're an advanced person, you may talk about binary lifting, but I'm just skipping that for now. Anyway, so yeah, so then now I can do something like naming things is always hard, but let's say node, right? And then here we just have the let's just call it longest. Outside, you might actually you can do this without a global-ish, I mean, it's not technically global, but global-ish variable, but by returning multiple values. I'm going to do it with the global here, but do practice doing it both ways, because some interviewers prefer it one way, some interviewers prefer it another way, so that's, up to you. If node is none, then we just return 0. Otherwise, okay. As we said, what is the longest path where node is the root, right? So basically here we just go, okay, so what is the longest path? So left is equal to get longest of node dot left, right is equal to get longest of node dot right, and then of course that means that now you have the longest path on the left and the longest path on the right, and then you combine them, you have left plus right plus 1 for the current node, and then that's the path or that's a possible longest path. So then you just compare it to what we have so far. Max. Right, and then now what we return, and then we ask ourselves, okay, so what is the longest path? Maybe this is actually, maybe I kind of comment here. This is what this should answer. I think the hard part about this problem is that what you're returning and what you're updating are two different things. And I think maybe I would take that back a little bit. Maybe if we had you return a tuple, for example, then it's more clear that the two components, and especially if you use the name tuple, how to kind of answer this question. So let me get the right answer first, and then we'll refactor this in a little bit. It is a easy, so I could spend a little more time. So then here we return the longest path, where this is the sub branch, right? So this is just max of left plus 1 or right plus 1, right? Yeah, and then now we can just do get longest of root and then return longest. Oops, can't spell longest, or can't spell return maybe. Yeah. Okay, maybe I'm off by 1, but let's see the length of the diameter of the tree. Longest path. Am I off by 1? Let's return 1 and 2. Oh, I see. Yeah, so I do return the length of the path. Oh, no. What I do is I return the node, the number of nodes in the path, because we just count the number of nodes effectively in the longest path. So we return it plus 1, so we have to minus 1 to return the path that is between them. Okay, so I think this is going to be right. So let's just actually let me show this a little bit for the viewers, and then let me just clarify it a little bit. And maybe this is something that I can practice with as well. In production code, I actually use this way often, something called name tuples, but I haven't done that in a long time. I haven't done Python professionally in a long time. So let me look up name tuples just to make sure I have the syntax correct. Name tuple. Okay, so you can say, let's just say, naming things is the hard part, but let's just say longest, longest wrapper. Let's just call it this for now. Maybe we can change it as we kind of figure out how to use this, right? Wrapper, and then basically we have two attributes that we want to do. One is the path to longest, maybe path to longest, and then longest path, something like that. Or path to deepest, maybe that's a better word. Yeah. And then now we can rewrite this in the following way. Now if node is none, what does that mean? That means that, wait, am I using this right? Oh, whoops, I think this should have. So then now the path to the deepest is going to be 0, and then the longest path is also going to be 0. Yeah, and then left we get these things, and we don't need this anymore. We don't need you anymore. But yeah, longest path then, right, is just equal to the max of. So then now, actually, the longest path here so far then is just equal to left dot longest path. Actually, I don't know. Yeah. Plus right dot. Oh wait, no. Sorry. Whoops, I messed that up. It is the deepest path on the left plus deepest path on the right. Sorry, I was too focused on name tuple syntax that I kind of wasn't focused. So yeah, so this is the longest path now, right? Because now this is the root, so you have the deepest path on the left and the deepest path on the right. And then path to deepest, is that the right way of? I don't need, all these words look weird to me now. But the path to the deepest is now, of course, left the deepest path on the left, or the deepest path on the right plus 1. Right, and then now at the very end we can of course return longest wrapper of path to deepest and longest path. And then now here we just start from the root. I call it wrapper, but I don't know. Like I said, you can think of what you want. But then now we just take the longest path minus 1, because this is the number of nodes on the longest path, which I find is more intuitive. I don't know. Maybe we could do it the other way too. Yeah. So this looks good, and this is how you do it without a global variable. Let's give it a submit before let's figure, actually, let's do the most obvious edge case, which is one node. And then I think we're good here for me. Oops, that's not the right one, is it? I wish there's just one where I can, not run the example cases, but copy the example cases to test case, because I think that's more useful anyway. So I guess now I can just do this and copy here. But anyway, let's give it a submit. It looks good, right? Oh, look, oh no, how did I made the same mistake 3 different times, huh? What am I doing wrong then? Maybe I misunderstood something? Dong dong dong. The problem is that this is annoying as a visualization. Oh, I guess, does this work? Oh, what is going on? It would be nicer if they could show me the entire tree, but okay. So the longest thing here is 7, or I return 7, but it expects 8. So -7 would be 6 or 5, I guess. So the longest path will probably be -9. So 1, 2, 3, 4, 5, 6, 7, 8. Huh? Did I have a typo? Oh, I don't have a typo, but I think when I rewrote the code, I was incorrect. Okay, I think I rushed it a little bit. That's my fault. Well, it's basically the longest path. So this is the longest. Okay. I was wondering why I didn't have to do it, but I don't know. I was sloppy, so that's my bad. I think I made different wrong answers previously, so we'll go review them afterwards. But yeah, so this is longest path where notice the root, but this is not the longest path on the subtree. What we want to do is return the longest path on the subtree, right? So then here, this should be max of, maybe I'll put it here then. So this is the longest path here, and then we can do so the longest path in the subtree, however, is either the longest path where this current node is the longest path, or left that longest path, or right that longest path, right? So that's basically, wow, how did I mess that up? But, you know, stuff happens, and I was full, my excuse, if you want to take it, I don't know if I borrow it, was that I was too focused on the name tuple. But yeah, after I fixed the name tuple, look, this is good. This is slower than previously, but that's fine, because I think previously I did the global variable, and I think global variable is probably faster. But you shouldn't optimize for speed on this magnitude. You should optimize for optimize for readability, and I think we did optimize for readability here. So I am learning with name tuples as well. I mean, it's something that I know to do in production code, but sometimes when you do Leetcode, or especially in competitive setting, you find yourself you optimize for time, right? But when you're in an interview, it doesn't matter if you solve something in 2 minutes or 3 minutes, or 5 minutes and 10 minutes. You should aim to be readable, especially if you have access to a computer and something like that. Because we on a whiteboard, maybe that's a little bit weirder. But anyway, so this is linear time because we look at each node exactly once, right? We do a recursion. This is the way that we do it is post order. So this is linear time. I am curious what I got in wrong answer on. Did I just missed it on one node or something? From a year and 6 months ago. Yeah, I guess I just missed it on one node. I don't know why I returned 13 though. Oh. I did do it with the more tricky way, which we'll talk about another time maybe, where, how did I do this? This one I did it. But I also, I missed 2 nodes. Well, this is an example case, right? So that's a little bit sad. Though this seems like what I wrote, so I don't know. Maybe this would have been wrong, because that's what I wrote initially. don't know. Oh, cause yeah, not sure. Anyway, I hope this is more readable, and I hope that you actually also see progress over time, because I think I'm becoming a little bit more readable. Just I would say that I have spent many years writing Python professionally, but not in the last maybe 5 years. So there's definitely new hardness that I'm not as good at. But also, just like I said on Leetcode, sometimes I will optimize for programming speed, not execution time speed, right? And as such, some code might be easier to write but harder to maintain. That said, if you do want to write long-term code, you probably want to rename these things a little bit better. But I'll leave that as an exercise at home for y'all. That's all I have with this one. I'll see y'all around. Stay good, stay healthy, to good mental health. I'll see you in another problem. Bye bye.